Welcome to the channel. Today in this tutorial let's talk about Tower of Hanoi problem. It looks like a simple game of moving disks, but it's actually a famous math puzzle that follows very strict rules. The goal is to move entire stack of disks from source rod to a destination rod using a helper rod so that they end up in the same order as they started. This is our problem, the pictorial representation. We have three rods named source, destination, helper and stack of disks in source rod arranged in pyramid shape. Our aim is to move all these disks from source rod to destination rod like this. And while moving the disks, we need to follow few rules. First, you can only move one disk at a time. Second, you can only take the top disk of a stack. And the most important rule, no big disk on top of a small ones. A small disk can never support a larger one. So larger disk can never placed on the top of the smaller disk. We need to place disk like this. And we can name these disks like this. Disk 5, disk 4, disk 3, disk 2, disk 1. When we have 5 disks. Okay, this is our problem. Next, let's talk about solution. So here we have 3 disks. Disk 1, disk 2, disk 3. Let's solve this problem. I'll first move this disk 1 to destination rod like this. Then in the next step, let's move this disk 2 to helper. Then I'll move disk 1 to helper. Just randomly move disks. Next I'll move disk 1 to source. Next let's move disk 2 to destination. Next let's move disk 1 to helper. Next let's move disk 2 to source. Next let's move disk 1 to source. I think I'm in a problem. We did move disk randomly. After making several random but valid moves, all the disks are again stacked on the source rod instead of reaching the destination. We return to the starting position. That is the thing. The Tower of Hanoi is not about randomness. Every single step is actually a well calculated mathematical move. If you miss even the very first move, the whole tower won't end up where you want it. If we can't move disks randomly, how to solve this problem? First of all, if the number of disks is odd, like 3 disks, 5 disks, our very first move must go from the source to destination. If you have an even number of disks, you would start by moving to the helper rod. That is, move disks from source rod to helper rod. That is the first move. So here we have 3 disk problem. Let's solve this. Let's use all legal moves. Okay. Here number of disk is 3. So first move disk 1 to destination like this. Next, after the first move, always make the only possible legal move that does not undo the previous move. So here step 1 is done. Next, step 2. Here we can move disk 1 as well as disk 2. If we move disk 1, we can move it to helper rod or source rod. If we move disk 1 to source rod, that means we are undoing the previous step, right? So we can't move that. Now if I move disk 1 to helper rod, then what is the use? If I want to move disk 1 to helper rod, we could have done that in the previous step, right? So that is also not valid choice. The next option is disk 2. We can move disk 2 from source to helper rod. So I'll move disk 2 from source to helper rod. We can't move disk 2 to destination because we can't place larger disk on the smaller disk. So here correct move is move disk 2 from source to helper rod. Next, we can move disk 1. We can move disk 1 to helper rod as well as source rod. And we can move disk 2. We can move disk 2 from helper rod to source rod. But if we do that, we are undoing the previous step. So that is not a valid choice. We can't move disk 3 to helper rod or destination rod because we can't place larger disk on the smaller disk. Here disk 2 and disk 1 are smaller than disk 3, right? That's why. So now we can move disk 1 to helper rod or source rod. I'll move disk 1 to helper rod because if I move disk 1 to helper rod, destination rod will be empty. Then I can move this disk 3 to destination rod. Our final aim is to move all the disks from the source rod to destination rod, right? And we need to place the disk in the pyramid shape. For that, first we need to move disk 3 from the source rod to destination rod, right? So to achieve that aim, I'll move disk 1 to helper rod. Next here, as I said previously, I'll move disk 3 to destination rod. That is our main aim. Next, to get the discs in the pyramid shape in the destination rod, next we need to move disk 2 to destination rod, right? To move disk 2 here, I need to move disk 1 first. I can't move disk 1 to destination rod because if I do that, I can't move disk 2 to destination later. We can't place larger disk on the smaller disk, right? So I'll move disk 1 to source rod here, like this. Now disk 2 is free. We can move disk 2 to destination, like this. Lastly, I'll move disk 1 from source to destination. Now we reached our goal. We successfully moved all the disks from source rod to destination rod with the help of helper rod. To do this, we took 7 steps. Here number of disk is 3, so it took 7 steps. What if number of disk is 4? Number of disk is 5. How to calculate minimum steps needed to solve this problem? For this, you can use 2 power n minus 1 formula. Here n is number of disk. If number of disk is 4, that is 15 steps. If number of disk is 5, 31 steps. That is the minimum steps we need to solve that problem. Now here, while moving the disk, sometimes we feel we have a choice. But remember, it is not a game of luck. Every step is a calculated move. So how to know that whether our move is a valid move? For that, we can use a cheat code to ensure that we never make a wrong turn. I'll explain about this cheat code in the next tutorial. Till then, take care.